Good morning, students. In this video, I will be discussing on what is ring topology. Okay. So in ring topology, you can see here each device has a dedicated point-to-point connection with only the two devices on either side of it. Means here you can see this is how the ring topology looks like. If I name these systems as system 1, system 2, system 3, system 4, system 5, and system 6. So what I'm telling here, every node has a dedicated point-to-point connection with only the two devices on either side of it. For example, if I see station 1, it can have the connection or it can communicate only to its neighboring nodes, that is either to station 6 or station 2. Similarly, station 2 can communicate either with station 1 or station 3, and station 3 can communicate either with station 2 or station 4. That's what there is a dedicated point-to-point link between two of its neighboring nodes, either left side and right side. So a signal is passed along the ring in one direction. Here signal is nothing but a token. So what happens in ring topology? A token will be passing in a clockwise direction. Normally it will be like this flow. A token will be go on moving from one node to the another node. So whichever the system wants to transfer the data, that will receive the token and it will start sending the data to its destination with the help of its neighboring nodes. So if station 3 wants to transfer to station 6, then it can use the station 4 node in a clockwise direction. Then station 4 will transfer to station 5 and station 5 will transfer to station 6. In this way, station 3 can transfer data to station 6. Once the data transmission is completed, then station 3 will release the token and the token will be go on moving in the clockwise direction in the ring fashion. So whichever the station wants to transfer the data next, then that station will receive that token and it will start sending the data. In that way, using the token system, the stations will start communicating or sending the data from one node to the another node. So that's what here I have written a point. Each device in the ring incorporates a repeater. So normally, for example, if station 1 wants to transfer to station 5, then it will take the help of station 2 or station 6. Normally it will take the help of station 2 since the data will move in the clockwise direction. So every station will have the repeaters in order to regenerate its energies. It should not means if I am sending any analog signal, the signal should not come down. So the energy level should be same. Thereby, every station will have the repeater that will help in regenerating its signal strength. So that's what here I mentioned. When a device receives a signal intended for another device, its repeater regenerates the bits and passes them along. That's what, so that the energy level of the signal should not come down. So in this way, the ring topology will work. So normally, this topology we can see in hospitals or in banks, where for every station a token is allocated. So whenever the token comes, a service is given to that particular node. Here also the same concept is used. Okay, but here there is one small problem. For example, see here in this token, sorry, in this ring, when the token is moving in the clockwise direction, in case if there is system 1, system 2, system 3 and system 4, okay, when the token is moving from system 1 to system 2, if the link is broken, means here like station 2 to station 3, a token is moving but there is a link has been shattered or there is a problem with the link, then what happens, the token can't move to the next node. If the token is not moving to the next node, then the token will not rotate in the ring. So at that time what happens, there is a concept known as a dual ring concept. So automatically there will be one more ring will be there in the ring topology which is in active state. So the moment when the active ring is having some problem, then immediately if you think that here there is a link problem, then a connection is given to the second ring. Then it makes an active, and in the anti-clockwise direction, the token will pass, so that the token can start moving in the anti-clockwise direction that can reach to all the nodes. So the token should not stop. So in that way, even if the link is broken, there is a concept known as a dual ring, which helps in sending the token or moving the token in the anti-clockwise direction, so that the data transmission should not stop. And one more problem is in case if the node gets failure. So what happens if the node think that station 2 is holding the token and the station 2 is having some problem. So at that time what happens, we are giving the lifetime for every token. So within a specific amount of time, if the token is not released to the next node, then immediately the protocol will think that there is some problem in the node, then that node will be removed from the network or necessary action will be taken by the protocol, thereby the token will be moved to the next node. So in this way, the token should never stop in the ring topology. It should be go on moving in the uh, ring fashion, so that whichever the node wants to access the whichever the node wants to send the data, it will take the token and then it will start transmitting the data. Either if there is a node failure or there is a link failure, then a necessary action will be taken. If there is a link failure, dual ring concept is available. If there is a node failure, then the protocol will take a necessary action, thereby the token can be moved to the next node. Okay. And we have few applications like we are using this ring topology mainly in office or buildings. Like I told you, the real-time example in hospitals or in banks, the token system is available. No? There we are using the ring topology. So we will see few advantages. So in ring topology is relatively easy to install and reconfigure. There is no much problem. In order to add or delete a device, any node, it requires changing only two connections, yes or no? For example, in the existing network, I want to add here one more node like S7. Then what I should do, I should give this node should be known to only S6 and S7. Those two configurations I need to do. And in order to give this S7 information to all the nodes except S1 and S6. So its neighboring nodes, the data should be or the information should be given. I need to do the changes. So that's what here the point. To add or delete a device, it requires changing only two connections. Its neighboring nodes, left side and right side. So fault isolation is also very simple. Easily you can identify if any failure is occurred. The main drawback is there is a unidirectional traffic. That's what I told you. Here the data will be moving only in the clockwise direction. For example, if system 1 wants to transfer to system 6, even though it's its neighboring node, but still the data should move in the S2, S3, S4, S5 and S6 only. It should move only in the one direction. That is the main drawback. And a break in the ring can disable the entire network. Yes. So for example, I told you if this link is broken, for example, the connection is broken between S2 to S3, this link is broken, then the entire network will stop because the token is stopped moving. Thereby communication will stop. The node will never get any token. So until the necessary action is taken, the whole network gets stopped. So hope so you understood. So I've also added bus topology as well as mesh topology in the description box. The video link is available. You can even watch those videos. Hope so you enjoyed the video. Subscribe my YouTube channel for more videos. Thank you. Bye.